Hi everyone, this lesson is about the cosine rule. This is another one that applies to any type of triangle, so scalene triangles, obtuse triangles, even right angle triangles, but it's more useful in scalene triangles. If we have right angle triangles, we just have the normal old SOHCAHTOA. So here is the cosine rule. A squared equals b squared plus c squared. Take 2bc times the cosine of angle A. And of course there's nothing special about writing it with A first. We could write this with any of the sides we choose first. If I choose to put, for instance, b squared as the subject, then the next two squared terms have to be the other sides. So a squared plus c squared. Then the subtract 2 is the same. Then the sides b and c here, they're the ones that were on the right hand side. Here I have a and c on the right hand side. And the cosine of the angle A, matches or is opposite to side A. So this one would be cosine of the angle opposite to B, so it would be cosine of angle B. Likewise, I could put c squared at the front, then the other two sides are A and B, they're both squared. Subtract, now it's those two repeated again, AB, and then cosine is for the angle that is opposite the side which is on the left there, so angle capital C. There's three different versions of the cosine rule. You don't have to memorize all three, but memorize the pattern. So let's apply the cosine rule to this triangle we've got over here. So I've got angle A. This would be little side A over here, which we don't know. This is angle C down on the bottom right. This 7.3 would be side C, and this one down the bottom here would be side B. Our question is find the unknown side length correct to one decimal place. So we're looking for the unknown side, which is A. So the easiest one to use would be the first one, because side A is already isolated on the left there. It's A squared admittedly, but it's better than having it over here in multiple places. So if you're looking for an unknown side, like this one here, A, start by writing that as the first part of your formula. Now remember the pattern, the other two sides. Now that reminds me a little bit of Pythagoras, so it's easy to remember that step. Then subtract 2, and it's the same edges that we already have here, BC, cosine, and the angle that we write for the cosine is the one that is opposite to that side on the other edge, so cosine A. That's the pattern. Now we can substitute what we've got. B equaled 8.6, which we square. C equals 7.3, which we square, minus 2 times 8.6 times 7.3 times the cosine, and angle A is 38 degrees. Remembering this is not the final answer, this is A squared. So the calculator will help us do this. Be careful that your calculator is set on degree mode when you're working with angles in degrees. And that gives me 28.3. That's the value of A squared. I'll just make a note. A squared is 28.31 if I round. Now my final answer, of course, I will need to take the square root of that answer. Please use the answer key. Don't retype a rounded off answer. So they said correct to one decimal place, so 5.3 centimetres if I round off. A equals 5.3 centimetres. Now always go back and have a quick look to see if it makes sense. 5.3 is of the same reasonable sort of size as these edges, and remember the old idea that any two of the edges must add up to be greater than the third edge. Otherwise it can't be a triangle. So that's true. 7.3 plus 5.3 is greater than 8.6. So that's good. That seems to work. That's just a quick little verification. Now, sometimes we get questions like this, where we've been given all three edges of the triangle and we need to find the size of the unknown angles. Again, this one is perfect for the cosine rule. So I'll do a quick sketch of the triangle first, and I'm not particularly trying to do this to scale. So I'll just mark angles A, B, C. Now little a equals 5.8. This would be over here. 5.8 centimetres. Little b equals 4 centimetres. And little c equals 6.4 centimetres. Again, I'll focus first of all on angle A as my unknown angle. So I'll write a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Now this time, angle A is my unknown, so I'm really trying to write this formula so that the cosine of angle A is the subject of the formula. And there's a multiplication sign here, and multiplication is a stronger link between the 2bc and the cosine A than this negative sign, the subtraction over here. So I think the first thing I'll do is I'll leave the a squared. I will add all of this. All of this will be added. So add 2bc cosine of A, and that just leaves b squared plus c squared on the other side. Now I think I could leave the 2bc cosine of A where it is. The b squared plus the c squared is there. Remember, without anything written in front, that's automatically a positive a squared. So subtracting a squared will take care of that. And now I can deal with this multiplication. I'm going to think of 2bc altogether multiplying by the cosine of A. So if I want the cosine of A, I've got b squared plus c squared, take a squared, all divided by 2bc. So I've started with my cosine rule, and I've rearranged it to make cosine of A the subject. And the numbers we had, which are up there, B was 4, C was 6.4, A was 5.8, divided by 2 times, now B was 4 and C was 6.4. Remember, this is the cosine of A. When I work all these numbers out, I'll end up with the cosine of A. So here I go. I'll need a fraction. 4 squared plus 6.4 squared. Take 5.8 squared over 2 times 4 times 6.4. Just have a quick look to make sure I typed that all right. And I have decimal 455. That's good. 0.455. And now A then, the angle, would be the inverse cosine of this number, 0.455. Once again, I'll need my calculator for this. So shift then the cosine key for inverse cosine, and again use the answer key. Do not just type 0.455, which is rounded off. You'll introduce rounding errors. And I have an angle 62.9 to 1 decimal place. 62.9 degrees. Now, the question said to find all of the unknown angles. I would have to do this same process again for angle B using the cosine rule, and I'd have to rearrange it differently this time, and I'd have to start off by writing this with a cosine of B in the formula. Then for the third angle C, you could use the cosine rule for a third time, or you could simply use the fact that all three angles must add to 180 degrees, and that's usually the quickest way to finish that one off. I'll let you finish this one off for yourselves, and that is a quick introduction to using the cosine rule. In this case, we were finding an unknown side where we had two known edges and an included angle, and in this one, we were finding an unknown angle when we knew all three sides. Thanks for watching.